let's go over this warm-up question. It says a marathon has 3 scattered starting times, each called a wave. Each wave then has 5 starting areas called corrals that runners are grouped into. Draw a tree diagram that shows the possible waves and corrals a runner could be assigned to. Over here it says waves are A, B, and C. So there's 3 of them. So you should be writing A, B, C. Does that make sense, everyone? Then there are 5 corrals, which means if they go into wave A, they could have 1, 2, 3, 4, 5 for the corrals, or they could go into B and do 1, 2, 3, 4, and 5, or they could go to C and do 1, 2, 3, 4, 5. Any questions on drawing tree diagrams? Now, obviously, we don't want to do tree diagrams for the really big problems, right, guys? Because that would be quite annoying. But for these smaller ones, it makes a lot of sense, right? Mm-hmm. So how many different wave and corral assignments are there? 15. So if there are 15 total combinations, if waves and corrals are randomly assigned, what's the probability they will get wave B in corral 5? 1 out of 15. Is that making sense, guys? So based on the fundamental counting principle that you guys did yesterday, we're now going to do compound events, which is another step further past the fundamental counting principle. So a compound event is the probability of 2 or more simple events. So it's the probability of 2 or more simple events. If you guys recall, we did simple events on Monday. That was like the probability of flipping heads was 1 out of 2. The probability of rolling a 4 was 1 out of 6. So it's this simple probability, and it's multiple simple probabilities being put together into one. That's a compound event. We can have what's called an independent event. An independent event is the outcome of one event does not affect the outcome of the other event. So what I mean by that is if I flip a coin, does my flipping of my coin affect me rolling my dice? No. Those probabilities don't affect one another. Does that make sense? What about if I roll the dice a first time and then I roll it a second time? Does my first roll affect my second roll? No. First roll doesn't affect your second roll. You still have everything there. Same thing with flipping a coin. Your first flip doesn't affect your second flip. So, or your spin of a spinner. Your first spin does not affect your second spin. Does that make sense, guys? So any time where the probability is not affected, it is called an independent event. So in order to find the probability of two independent events is found by multiplying the probability of the first event by the probability of the second event. And if there's more than two events, then you just keep multiplying it by all of the events. Okay? You do them all individually, all separately, okay? So if I'm going to do number 1, it says, what is the probability of rolling a standard die twice and getting an even number and then getting a 5? So question is this, I want an even number and then I want a 5. So if I have a dice in my hand, what's the probability that I'm going to get an even number? 3 out of 6. And we like to put everything into simplest form because it makes our math easier, right, guys? So 3/6 simplifies down to 1/2. So I have a probability of 1/2 getting an even number when I roll that dice. Does that make sense? Then I roll that dice again. What's the probability that I'm going to get a 5? And what did it tell us to do when we have our two simple events? How do we combine them together? So 1/2 times 1/6 is 1/12. Because 1/2 times 1/6 is 1/12. So you have a 1/12 chance of rolling an even number, picking that dice up, and rolling a 5. Does that make sense, guys? So then if we go to number 2, what's the probability of tossing a coin 3 times and getting tails each time? So if you have a coin in your hand and you flip it, what's the probability you'll get a tails? If you pick that coin up and you flip it again, what's the probability you'll get a tails? Pick that coin up one more time and flip it. What's the probability you'll get a tails? And what operation do we do to combine all 3 of them together? Please be careful when you multiply by 2 many times, because I get students who get that wrong all the time, so be very careful. 1/2 times 1/2 times 1/2 is 1/8. Please don't tell me 1/6. So you have a 1 out of 8 chance of flipping tails 3 times in a row. Does that make sense, guys? Any questions so far? Okay, let's go to number 3. If the spinner to the left is spun once, find each probability. So I have this first spinner that's numbered 1 to 12. 4 of the numbers are shaded. Does that make sense to everyone? Then I have the spinner below it. What do you notice about the spinner below it? There are how many sections? And are they all different colors? No, some of those colors repeat, don't they? You have to make sure you look at that spinner. Don't assume that it is all different colors. Does that make sense, guys? Make sure you look at it. Same thing with the numbers. Always double check everything before you do anything. Okay, so tell me this, guys. What's the probability that I will get an 11? 1/12. What's the probability that I'm going to get a red? 2. And what do I do with those 2 fractions? Multiply. Okay, now here's where we have to remember. You guys know how to multiply fractions, but what can I do to make my life easier? I want to cross cancel because then I don't have to multiply, cross, and simplify. It is so much easier if you cross cancel. What can I cross cancel? 2. So the 2 becomes a what? And the 12 becomes a what? 6. Now that you've cross canceled, now multiply across. And what do you get when you multiply across? 1/3. And because of that, I don't need to simplify. So simplify your fractions before you write them and cross cancel, and it'll make your answer easier, and hopefully you won't have to simplify in the end. Does that make sense, guys? Questions? Okay, do B, C, and D only with your partner. Go. Okay, so what's the probability that I will get an unshaded one? Why 2/3? Because it should be 8/12, and when you simplify it, it will become 2/3. Simplify your fractions. It makes your math easier if you simplify from the get-go, okay? So I'm going to take 2/3, and I'm going to multiply that by the probability of getting green. What's the probability I will get a green, everyone? 2. Can I cross cancel? So what do I get when I multiply across? 4/15. So you have a 4 out of 15 chance of spinning an unshaded number and spinning the color green. Okay, what about the probability of at least 3? 10/12, which simplifies down to? 5. Good, and we're going to multiply that by the probability of getting blue, which is? 1/5. Can I cross cancel? Yes. What do those 5s become? 1. So my answer is what? 1/6. So you have a 1/6 chance of spinning at least a 3 and a blue. Does that make sense, guys? Find them separately, combine them together with multiplying. D, what's the probability of getting an even and shaded? So I want an even and a shaded. 1/6. It has to be even and shaded, meaning it has to be both even and shaded. If it would have said the word or, then you guys would have been correct. Does that make sense? But the word and means I have to have both of them, not them both separate. Does that make sense, guys? Bennett.
If it said even or shaded, would you count like the shaded and even would you count 3 twice?
No, good question. You'd only count it once. So if it said even or shaded, you'd count the 4 shaded, so you'd get 4. And then you count all the even numbers that are not shaded. So 4, 5, 6, 7, 8. So it'd be 8 out of 12. Does that make sense, guys? The difference between the word or and the word and. Because I know that's tricky. And has to be both of them, or can be one or the other. Okay, then what's the probability of not getting a red, you guys?
3/5.
3/5. Can I cross cancel?
Yes.
What's the 3 become?
1.
And the 6 becomes a?
2.
Multiply across, what do we get? 1/10. Questions on that at all? Okay, we're going to skip number 4. We'll probably come back to it. Most likely we won't do number 4 till Monday because we're going to continue practicing compound events on Monday. And we're going to skip the top part, so we're going to go down to the bottom part now where it says dependent events. So we just talked about independent events. Independent events are 2 events that do not affect one another. You find the probability of one, find the probability of the other, and multiply the 2 together. Where dependent events, the outcome of one affects the outcome of the other. Which means whatever happens the first time is affecting your second option. Your second affects your third affects your fourth, and so on down the line. So the probability of 2 dependent events is still found by multiplying the 2 together. So you're still multiplying your 2 fractions together. Your fractions are just going to be a little different because your second event is affected by the first. Braden.
Does the dependent event have to affect you?
Yes.
Okay.
Yes, it does. It has to affect. Otherwise, if it doesn't affect, it's an independent one. Do we see the difference between independent and dependent? Okay, so if we look at example number 7, it says there are 3 green markers, 6 yellow markers, 4 red markers, and 12 blue markers in a pencil box. So if I had a pencil box in front of me, I have all of those markers in front of me. A marker is drawn, not replaced, meaning I take that marker out and I put it off to the side. It's not replaced. It does not go back into my pencil box. Does that make sense? After I've drawn the first one, I've set it off to the side, then another marker is drawn. And we got to find the probabilities of all these things. What's the first thing I need to do before I can even start figuring out A, B, C, and D? What do I got to do first, Addison? I need my total, right, guys? Find your total, write it down right here. How many, everyone? Okay, so help me out. There are 25 total. I want to know the probability I'll get a red. What's the probability I'm going to get a red? 4 25ths. Because there's 25 total, right, guys? Okay, I took that red marker. I took it out. I set it off to the side. How many total markers are in my pencil box now?
24.
So it's no longer out of 25, it's out of? So I'm going to multiply that out of 24. Does that make sense to everyone? When you take one away, you got to take one away from your total. Now, how many blue markers are there? 12. So that means my probability of getting a blue marker is 12 out of 24. Is that understood? Okay? What should I do with 12/24 before I do anything? And what does 12/24 simplify to? So I'm going to take out that 12/24, and I'm going to change it to a 1/2 because that's going to make my math easier. Right, guys? What should I do now? Cross cancel. What can I cross cancel? 4 becomes a 2 becomes a
1.
What do I do now? What do we get when we multiply straight across? So do you see how the probability of the first event affected the probability of the second one? Okay, hold on, girls. Let me get through all this, okay? Let's do C, and then you guys can ask me your questions, okay? So C, I want the probability that they are both blue. So all my markers are back in my pencil box. What's the probability I'm going to get a blue marker? 12/25, because there are 12 blue in my box out of 25. I took that blue marker and I put it off to the side. I want the probability of another blue marker. So if I took that blue marker and I set it off to the side, how many blue markers do I have now?
11.
And how many total markers do I have? Did that make sense to everyone? What do I do now? Cross cancel. What's that 12 become? 24? What do I do now? What do I get when I multiply straight across? So you have 11 out of 50 chance of pulling a blue marker out and then another blue marker out, meaning pulling 2 blue markers out in a row without replacing the first. Does that make sense? Morgan, what's your question?
So why would you only change it to 24?
Because you're only taking one marker out.
Okay.
Like if I have a box of 25 markers and I take that red one out, toss it, throw it away. Vince needs it, I throw it to him. I only have 24 markers left in my pencil box. That's why it's 24.
So will it always just be -1?
Unless you're taking out more than one thing, yes. If I were to do another one and say, let's say I said, and then yellow, then it would be 6 out of 23 because I took another marker out. Does that make sense? Okay? Does that make sense? Okay. Bella, what's your question?
I was sorry. For A, why did you, since you took away 4, like since it said 4/25, why would you only change it to 24 and not to 21?
I didn't take away 4. I only took out one marker. There are 4 chances to get a red, but I didn't take out all 4 markers. I only took out 1. I didn't take out 4. 4 is just your probability of getting that color, but I'm only taking that one marker out and I'm throwing it away. So I'm only taking one away. Good question. Other questions, you guys? Does that make sense? Please do B and D with your partner, and then we will go over it. Go. Okay, so back to the beginning. All the markers are in my box. What's the probability I'll get a yellow marker, everyone? Good, because there's 6 out of 25. Now remember, I take that yellow yellow marker, and I throw it away. What's the probability I will now get a green marker? And what can I do with 3/24 to make my problem easier?
1/8.
Simplify it to?
1/8.
And now what do I do? 6 becomes a? 8 becomes a? What do I do now? What do I get? So you have a 3 out of 100 chance, 3% chance of pulling out a yellow and then pulling out a green. Addison.
Me and Morgan, we didn't make it 1/8. We just crossed both.
Yep. Yep, that's fine. Yep, that's the beauty of it. No matter what, you should still come out with the same answer. Either way works. Whatever works best for you. All right, now I want the probability of both yellows. So first of all, what's the probability of getting a yellow? Okay, what's the probability of getting a yellow the second time?
5/24.
Good, because remember, we took that marker and threw it away. So now what do I do? 6 becomes a? 24 becomes a? 5 becomes a? 25 becomes a? And when I multiply across, I get?
1/28.
So you have a 1/20th chance, a 5% chance of picking 2 yellows in a row without replacing the first. Questions? Is this making sense? Okay, we are going to save the rest of the problems in your notebook for Monday. So it means you guys can either put your notebook away or keep it out, but get your worksheet, your homework out. Okay, let's kind of go over this problem by problem. Make sure you understand what you're doing. You are doing pages 15 and 16 for homework. It is due when?
Monday.
Monday, because we don't have class tomorrow. Got it, guys?
Yeah.
Okay? So, you need to give me the answer as a what? Does it say anything about decimals or percentages? No. You are still allowed to use a calculator. But you do not need to give me decimals or percentages. Is that understood? Okay. Starting at number 1, it says a dice is rolled twice. Is that an independent event or a dependent event? It's independent because the first roll does not affect the second roll. So label that independent, just like right there or something. So you will answer A, B, C, D, E, F based on 2 dice. Move to number 2. A coin is tossed, and then the letter of the word Indianapolis is selected at random. Is that independent or dependent? Independent. Write that down that that's independent. And then you will do A, B, C, D based off of that one. Number 3. The spinner below is spun, and then a month of the year is randomly selected. Independent or dependent?
Independent.
Write down that it's independent, and you will do A, B, C, and D based off of that. Number 4 says a jar contains 8 green, 4 blue, 10 red, and 2 yellow Skittles. A Skittle is randomly drawn, replaced, then another is drawn. Is that independent or dependent?
Independent.
Independent. Because you're replacing it, your probability doesn't change. So it is independent. And then you'll do A, B, C, D on number 4. Any questions on page 15? Even if you looked at all the A, B, C's, D's. If you looked through all those, do you have any questions on any of them? Okay, page 16. 5 says a piggy bank contains 4 quarters, 18 dimes, 10 nickels, and 8 pennies. A coin is chosen at random, not replaced, then another is chosen. Independent or dependent? Dependent. This one is dependent. So you'll do A, B, C, D, E, and F based off of number 5. It is dependent, so remember how that affects your probability. Number 5 is a math class is playing a game with 16 questions that uses the board below. Once a question is called, it is not called again. Find the probability of the first 2 questions called. Independent or dependent? Dependent. Dependent. So write down that that's dependent. And then you'll do A, B, C, D, E, and F based off of that. Okay, then 6, 7, 8, and 9 are just questions. So you guys will have to determine if those are independent or dependent based on what the question is asking you. Is that understood? All right, you guys have the rest of class to work, which means you have, 12-ish minutes, something like that. Sound good? All right, use your time wisely.
This is not a good